Hello everyone. Welcome back to Voltage Equation. Today we're going to talk about a phenomenon that we've all experienced at some point. Static electricity and why we get those annoying shocks when we touch an object or person. Ready to find out why this happens? Let's get to it. Surely you've seen one of these videos before. No, it's not magic, it's static electricity. To understand why we get shocks, we first need to know what static electricity is. Static electricity is a buildup of electric charge on the surface of an object. This charge can accumulate when two different materials rub against each other, causing electrons to transfer from one material to the other. Let's imagine you're walking on a carpet. As you do so, your shoes are in constant contact and friction with the carpet. This causes electrons, which are negatively charged particles, to move from the carpet to your shoes or vice versa. As a result, your body can accumulate an additional electric charge. So, what happens when you touch a doorknob or another person? Well, the shock you feel is the result of the discharge of accumulated static electricity. Electricity always seeks to balance itself, so when you touch something grounded, like a metal doorknob, the electrons in your body quickly jump to the object, creating that small spark you feel as a shock. This rapid flow of electrons is what causes that small shock sensation. And yes, it can be quite startling. But what happens when we touch another person? Well, the principle is the same. If one person has accumulated a static charge and the other hasn't, the electrons will seek to balance out by moving from the person with excess electrons to the other. This rapid transfer of electrons is what we feel as a shock or a small zap. Now, let's talk about the factors that can increase the likelihood of experiencing static electricity. There are several factors that contribute in our daily environment. A dry climate is one of the main culprits. In low humidity conditions, the air doesn't contain enough water vapor to dissipate electric charges. This means that in dry environments, like during winter, you're much more likely to accumulate static electricity. The clothing we wear also plays a significant role. Synthetic materials like polyester and nylon tend to accumulate more static electricity compared to natural materials like cotton. This is due to the properties of synthetic materials that facilitate the movement of electrons. The type of floor and the surfaces we interact with also affect the buildup of static electricity. Walking on carpets, especially synthetic ones, can increase static charge in your body. Similarly, sitting on plastic chairs or working on plastic surfaces can contribute to this effect. Movement and friction are key factors in the buildup of static electricity. Every time you rub two different materials together, like walking with shoes on a carpet, electrons transfer from one material to another, creating a buildup of charge. The frequent use of electronic devices can contribute to the buildup of static charge. These devices, especially those with plastic surfaces, can generate and accumulate static charges with continuous use. To demonstrate how static electricity works, let's conduct a simple experiment. All you need is a balloon and your hair. After rubbing the balloon, we've transferred electrons from your hair to the balloon, making it negatively charged. Now, let's bring it close to the hair on my arm and observe what happens. The negatively charged balloon induces a positive charge in the hair on my arm due to the attraction of opposite charges. This causes the hair to rise and be drawn towards the balloon. This experiment clearly shows how static electricity can generate an attractive force between objects. It's a fun and visual way to see physics in action. The static electricity we've been discussing is closely related to a phenomenon called triboelectricity. Triboelectricity refers to the generation of electric charge through the contact and separation of two different materials. When two materials rub against each other, one of them tends to lose electrons and the other to gain them. This electron exchange creates a charge difference between the materials. The triboelectric series is a list that classifies materials based on their tendency to either gain or lose electrons. Triboelectricity is present in many aspects of our daily life. For example, when you remove clothes from the dryer, you often find that they cling to each other due to triboelectricity. Or, as we saw in our experiment, rubbing a balloon with hair is a classic example of triboelectricity. Tired of those annoying shocks? Here are some tips to reduce static electricity. Applying lotion to your skin can help dissipate the electric charge. Opt for clothing made from natural materials to reduce the buildup of static electricity. Frequently touching metal surfaces. This can help discharge the static electricity accumulated in your body. These simple steps can help you avoid those bothersome shocks. And there you have it. Now you know why we get those shocks and how to prevent them. If you enjoyed this video, make sure to give it a thumbs up, subscribe to the channel, and hit the notification bell so you don't miss any of our future videos. See you next time on Voltage Equation.